It's critical to know when balancing a chemical equation that the number that you're fiddling with is the coefficient. You do not balance a chemical equation by changing a subscript. Now, you have fiddled around with subscripts, but that was to make a molecule charge neutral. For example, when you paired an aluminum with an oxygen and you needed to make that compound charge neutral, you wound up putting a 2 after the aluminum and a 3 after the oxygen. Here you had to fiddle around with the subscripts to make the compound charge neutral. So, subscripts are making a compound charge neutral, but coefficients are used for balancing the chemical equation. So let's look at that by way of example. First, showing you what you should not do. If you're trying to balance this chemical equation, it's true you could balance it by changing a subscript. And indeed, H2 plus O2 does give you H2O2. That's a balanced chemical equation. What's the problem here? The problem is you've now changed the chemical reaction itself. You're now combining hydrogen to oxygen to produce hydrogen peroxide, H2O2. But that's not the equation you were asked to balance. You were asked to balance the equation H2 plus O2 goes to water. So you do not balance a chemical equation by changing a subscript. What we've seen earlier is that you balance a chemical equation by changing the coefficients. The next obvious question then is, how does one exactly go about balancing a chemical equation? First, realize that balancing a chemical equation is essentially a trial and error process. And that's a bad deal when taking an exam, because if you spend too much time with a trial and error process on just a very few problems, it'll chew up too much time. But the good news is there are many recommendations and procedures that will help steer you in the correct direction when you're balancing a chemical equation so that it's done quickly and more efficiently. I'm going to teach you a method that I've worked on over the years for balancing chemical equations called the twin elements method, or sometimes I refer to it as the paired elements method. But realize that you can use any method that you want to balance a chemical equation. You can use the way your high school teacher taught you, or the way that you've learned on Khan Academy, or the way that I teach you. It doesn't matter. What matters is that you can balance a chemical equation, not that you necessarily do it my way. What I would like to do now is to give you a 30,000-foot overview of the twin elements method. It will be discussed in detail in the next video, but for now I would just like to give you a brief overview. The key is to identify two components. One is what's referred to as lone elements. This is any element that is all by itself that's not part of a chemical compound. For example, if you look at the provided equation there, you see that there's only one lone element, oxygen. The second species that you want to identify is where the name comes from, the twin elements. And a twin is two things that are identical. So here we go. Looking at this equation, is carbon a twin? Yes, it is. It appears once and only once on the reactant side and once and only once on the product side. Since there's only two of them, and since they are identical, we refer to them as twin. And what I found is a great help is to underline every twin element, because I'm going to come back and use that information later. And I don't have to rethink through it. I just look to see what I've underlined. Well, let's look at all of the elements in the reaction to see if we have any other ones. How about hydrogen? Yes, it's a twin. The symbol appears once and only once on the reactant side and once and only once on the product side. Warning, do not be confused. We are not looking at subscripts. We're only looking at the symbol. It is the symbol that's paired, not the number of atoms. Well, let's look at the last one, oxygen. Is it also, I know this oxygen is a lone element, but it is also a twin. In this case, no, because it appears 3 times. If anything, it's a triplet. It's certainly not a twin. So all we have to do is identify 2 chemical species to get a very good handle on where we need to start balancing the chemical equation. And the recommendation is to start with the paired element with the largest subscript. Notice the subscript on every underlined element. The largest one is the 4 in CH4 or methane. We would start from there and balance the equation using the rules that we're going to teach you on the next video. And if things work out, you'll get a good indication of where to end, and we will also look at a couple of tricks to help you get there quicker. Once you go through the video and have the essence of how to balance a chemical equation using the twin elements method, perchance it prove useful, I provided a flow diagram of the basic fundamental steps, as well as a few checking questions of once you're through balancing the chemical equation, to actually confirm that it is indeed a balanced chemical equation in proper form. So onward to the next video for the details.